Welcome back. In today's video, we're asked to express the current waveform I of t in standard cosine and then determine its amplitude, frequency, and phase angle, and B, evaluate at 0.1 nanoseconds. Standard cosine is positive cosine, so we express our waveforms in positive cosine in AC analysis. Thus, we can use a useful trigonometric identity to get a positive cosine. So we have cosine of x is equal to negative cosine x plus or minus 180 degrees. In our case, we see that our angle, phase angle, is 60 in our given. So thus, we're going to positive 60, so we're going to subtract 180. So subtracting 180, we end up with a positive cosine of 0.2, well, 0.2 cosine of 6 pi. I like to write this as e to the 9 times t negative 120 degrees, and that's in the milliamps. Our phase, well, not our phase, but our amplitude, we know that our amplitude is A is equal to 0.2. Our frequency, well, angular frequency omega is equal to 2 pi times f. So frequency is equal to omega divided by 2 pi. And that is equal to 3 to the 3e to the 9, but we can write that as 3 gigahertz. Our, in this case, okay, so now we need to find the phase angle. Well, the phase angle is at this point negative. So our phase angle is negative 120 degrees. So we have all we need. So now we can evaluate I of t at 0.1 nanosecond. So in this case, we could go ahead and evaluate omega t. Well, omega times t, and omega is measured in radians per second, and time is measured in second. So the second is going to cancel out, and we're going to left with radians, and we can transform that or convert that to degree, and then minus 120 from whatever this evaluate to, and then evaluate 0.2 cosine of whatever is in the parenthesis. So we can go ahead and say that omega t is equal to 6 pi e to the 9, and t is 0.1 nanoseconds, so that is 1 over 10, and we can just write that as e to the negative 9 over 10. These cancel out, so we thus end up with 3 pi over 5. We then can convert 3 pi over 5 to degrees, and I'm just doing this by hand. We can then convert 3 pi to degrees, and that is degree is equal to 180 all over pi, and we times that by radians, and our radians is 3 pi over 5. Pi goes away, 5 into that, so we end up with 108 degrees. So I of 0.1 nanoseconds is equal to 0.2 cosine 108 degrees minus 120, and that is equal to, in radian, 0.1688 milliamp, or in degrees, it is equal to 0.1956 milliamp. And this is B, and this is A. And that's it for today's problem. So I'll see you in the next one. Bye.